So now we're gonna discuss the second problem from day 6, that is the linked list cycle. So what the problem states, we are given the head of the linked list and we have to determine if the linked list has a cycle. Okay, so there we are given the head of a linked list. We have to determine if the linked list has a cycle in it. So how will we approach this question? So we are given a linked list. So this is our linked list, and this the one that are written in red are the address for the corresponding node. So for the node 3 the address is 100, for node 2 that is 200, for node 0 that is 300, for node 1 the address is 400. And what we'll do, we'll traverse the linked list. We'll traverse the linked list from the start, that is the start of the linked list. We'll traverse the whole linked list and store the corresponding address in the hash map. So we'll be using an auxiliary space of hash map, and what we'll do, we use a temporary pointer to traverse the linked list, and at every step we want to compare if the address of the corresponding node exists in the hash map or not. If it exists, we're gonna say that we uh, that there is a cycle in the linked list. So what we're gonna do, let's suppose at the starting let me take another mark. At the starting, our temp pointer is pointing to the head of the node. Okay. So what we'll do, we'll compare, we'll check if the value, if the address of the node 3 is present in the hash map. So currently our hash map is empty, so it is not present in the hash map. We'll move to the next node, and before moving to the next node, we store the address of the current node in the hash map. So we'll store 100 in the hash map. Okay, the address of the particular node in the hash map, and we'll move to the next node. So the next node is this. So this is the next node. So now again we're gonna compare, we're gonna check if the address of a particular node exists in the hash map. No, 200 does not exist in the hash map. So we'll move to the next node. Before it, we'll store the address of the current node in the hash map. Store the address of the current node in the hash map, and we'll move to the next node. And again we're gonna do the same step. We're gonna check if the address of the corresponding node exists in the hash map. No, 300 does not exist in the hash map. So we'll move to the next node. Before it, we store the address of the current node in the hash map. Okay, so we'll store the current node in the hash map, and we'll move the next node. Now our current node is 1. We again check if the address of the node 1 exists in the hash map. No, 400 does not exist in the hash map. So what we'll do, we'll store its address 400 in the hash map, and moves to the next node. So the next node points to this particular node. Okay, this particular. Now again what we're gonna do, we're gonna check if the address of the current node exists in the hash map. No, yes. The address of the current node exists in the hash map. So we have found a cycle in the hash map. So whenever the address of the current node found in the hash map, we're gonna return our answer as true. So this is the particular approach to solve the question to detect cycle in the linked list. So this approach will take the time complexity of order of n, because we have to traverse the whole linked list in the worst case, and the space complexity of order of n, because we have to store the address of the nodes in the hash map. Okay, so this is the particular approach. Now I will discuss the C++ code for the particular approach. So what is given in the function, we have the function name as hash cycle, that will return a bool type and receive the parameter as list node head, that is the head of the particular linked list. And if the head is equals to null pointer, so it is basically the condition when there are no nodes in the linked list, we're going to return false. So if this condition do not satisfy, we'll move to the next step and store the head of our linked list in the temporary pointer. Okay, in the starting we have stored the output, the value which we will return from the function. We have maintained a variable named output, and initially its value is initialized to false. We have maintained an unordered set to store the address of a particular node and to check if the address of a particular node exists in the unordered set or not. So we are using a while loop to traverse the linked list, and in the while loop we have specified the condition. The condition states that until we reach the end of the linked list, we're gonna traverse it. Okay. So in the while loop we have written a if statement, and in the if statement we are checking a condition. If the address of a particular node exists in the unordered set, we have found our answer. We're gonna find our answer because we have detected a cycle. We're gonna store the value of true in the output variable, and we're going to break the loop. And if this condition do not satisfy, we're going to insert the address of particular node in the unordered set and move to the next one. So this is the particular loop that is the most important part of our program, and at the end we'll return the output. Okay, so I have previously submitted this code. So this is the particular approach to solve the problem, and I will discuss another approach to solve this problem, that is the two pointer approach using the slow and the fast pointer. So what is the optimal approach to solve this problem? Uh, this is the given linked list. We have to detect if there exists a cycle in the linked list or not. Okay, so we'll maintain two pointers named the slow and the fast pointer. The starting, these will be pointing to the head of the linked list. And at every step, what we'll do, we'll move slow pointer by one step and fast pointer by two step. And what we're gonna do, we're gonna check if the slow and fast pointer become equals, and if the slow and the fast pointer become equal at any point in the linked list, so there exists a cycle. And if the fast pointer have reached the end node, or have or we have traversed the whole linked list using the fast pointer, that means that the fast pointer is pointing to null. Then what we're gonna do, we're gonna end our loop and we'll return false, as there is no cycle in the linked list. So we're gonna discuss two test cases to verify this condition. So one of the test case is using this linked list. So at the starting we have the slow and the fast pointer. So slow pointer will take one step and fast pointer will take two steps. So I will put this one. So slow pointer will take one step and fast pointer will take two steps, and we wanna check if at any point of the time in the linked list the slow and the fast pointer meet, and if these two pointer meet each other, there exists a cycle in the linked list. And if there is a condition the fast pointer reaches the end of the linked list, then there might not be any cycle in the linked list. So the fast pointer take two steps and the slow pointer take one step. So from the starting, slow move one step, fast move two step. So two step, one from here to here, and one from here to here. So two step, fast has reached this much. Okay. Again, slow and fast is not equal. We'll again move slow to the next and fast to the fast jump by two step. So one jump to note this, the second jump to note this. So let me rub this. So our fast pointer has reached this. So our fast pointer is at this node, the two node, and the slow pointer is present at the node 0. Okay, the slow pointer is present at the node 0. So what is the given condition? Fast is at the node second and the slow is at node 0. Okay, so again slow and fast pointer are not equal, so we'll move fast pointer by two step 1 and 2. So fast has reached here because 1 and here 2. Fast pointer has reached here and slow pointer has also reached the node 1. So the fast pointer and the slow pointer meets. So that means there exists a cycle in the linked list. And if we'll check for the case if there is no cycle present in the linked list, let's take a sample test case. This is a linked list. In this, no cycle is present. So at the starting, we have the two pointers, fast pointer and the slow pointer, pointing to the head of the linked list. We move slow pointer by the 1 step and fast pointer by the 2 step. So slow and fast pointer are not equal. We move slow pointer by 1 step and fast pointer by 2 steps. So 1 step to this and next step the fast pointer will be pointing to null. And if the fast pointer has become equals to null, we're going to return that is there is no cycle present in the list. We'll return false. So this is the particular approach which we'll follow to detect the cycle in the linked list, and more we'll discuss the code of. So now we'll discuss the code for the discussed approach. We have a function named hash cycle that will return a boolean type, and it has received a parameter, the head of the linked list, and if the head of the linked list is equals to null, we'll return null. We'll return null, or what we'll return false, because we have to return the boolean type now. The false itself equals to false. The null is itself equals to false, but we'll explicitly write false. And we'll use two pointers, the slow and the fast pointer. Initially both are pointing to the head of the linked list, and we'll use a while loop to traverse the linked list, and our while loop will terminate when the fast pointer become equals to null. This is the first case. In the second case, we'll traverse the linked list until the node at which the fast pointer is present, and the next node to the fast pointer is null, because that means when the fast pointer has reached the end of the linked list, we'll terminate the loop. Okay, we'll terminate the loop saying that we have not found any cycle in the linked list. So what we'll do, we'll move slow by 1 step and fast by 2 steps at a time, and we'll check if the slow equals to fast, we'll return true, else we'll return false. And if we have found that the slow equals to fast, we'll return explicitly from the function that we have found the cycle. Otherwise, if the return statement, if these conditions do not satisfy in the while loop, and the while loop terminates, we'll return false. So this is the approach. We'll run the code and check we have successfully executed our program. We'll try to submit it. So it has submitted successfully. So this is the approach to solve the problem, detect cycle in the linked list. It is a very easy problem. If you have any doubt, you can ask in the comments.